Hi folks, I'm going to do a quick video to revise distance, speed, displacement and velocity. To help us revise this, we're going to use our friend Sheila the sheep, and Sheila is going to be travelling up and down our one-dimensional universe. Let's say she starts at home, and home is defined as 0. Well, if she moves 1 metre, she can either end up here or here, so I better make this axis in meters. If she moves 2 metres, she can end up here and here. And this is the problem with distance. Distance tells me how far, but it doesn't tell me the direction. To get over this problem, we're going to define something called displacement. So displacement, it is a distance, it's similar to distance, but it's in a given direction. That's very, very important. And the sign of the number tells you the direction. Now, in physics, when a quantity has an associated direction, we refer to that quantity as being a vector quantity. So displacement is a vector quantity. Okay, so let's have a look at this number line now. Say for instance I tell you that someone has moved a distance of 2 metres. Well, that person could either have moved here, because that's 2 metres, and that's 2 metres. So there's 2 possible places here and here that the person could be at. If I tell you a person has moved a displacement of 2 metres, that person can only be here. Because the positive number refers to the positive direction, and I have decided to make this side the positive direction. So when you lay out your axes, you decide which side is positive. In this example, I've given the positive side as being down here, therefore it has to be there. If I say to you the displacement is minus 3 metres, the minus indicates the direction, so the direction is going to be down here, and minus 3, it can only exist at this point here. So by defining a displacement, you define exactly where something is. Now, if I came along and I said, the person is a distance of minus 4 away from something, that doesn't make any sense, because the minus shouldn't be there, because a distance can't be minus, but a displacement can be, and the minus merely tells you what direction it is in. So that's distance and displacement. Let's move on to speed. Speed, I think we all know the equation for. Speed is equal to distance over time. If you measure the distance in meters, say, and you measure the time in seconds, well, then the unit of speed is going to be meters per second. But there's loads of different units of speed we can use. If I measure the distance in, miles and time in hours, you will get miles per hour. So the units you put into the equation are the units you get out. So if that was miles and this is hours, well then that unit is going to be miles per hour, and that's how you say that. The slash is set as per. Okay, so now if I come along to you and I say, okay, Sheila moves a distance of 4 metres in 2 seconds. What's her speed? Well, that's no problem at all. I just say speed equals distance over time, which is equal to 4 metres over 2 seconds. So the speed's going to be equal to 2 metres over seconds, or 2 metres per second. The problem is with speed, say for instance Sheila started in the middle at the origin, we don't know if she's going 2 metres a second in that direction or 2 metres a second in that direction. So we've got 2 possible movements from our piece of information. So a better piece of information to give someone is the velocity. And the velocity, it's very similar to speed, except it's in a given direction. So again, velocity is going to be a vector quantity. The positive velocity must be in the same direction as the positive displacement. So, hang on, I'll just go back here. In this example here, if I make this number for the displacement measured in meters, if I make that the positive side, well that means if I say that someone has a velocity of 3 metres a second, that means they're going this way. If someone has a velocity of minus 3 metres a second, it means they're going that way. The minus merely indicates what direction they are travelling. Okay, the equation for velocity that you need to learn off is, this symbol here is referred to as delta, so it's the change in displacement divided by the time. Now delta means change in, so velocity, change in displacement over time. So I'm going to do a quick thing on the change in displacement. So when you're calculating the change in something, let's do this for an example of a bank account. Let's say at the start of September there's £1,000 in my bank account, and at the end of September there's £630 in my bank account. My change in money is my final balance minus my initial balance, so the change is minus £370, and I'm pretty upset about that. Now, a totally different situation is that at the start of September I've got £500, and at the end of September I've got £870. The change in money is, again, the number is 370, but this time it's a plus number. So I'm going to be pretty happy about that. So the sign is absolutely crucial, and the general rule for getting the change in anything is what you do. So the sign is very important, and to get the change in anything, it's merely the final value. It's the final value minus the initial value, and that gets you the change in. Okay, so let's do an example. So back to Sheila the sheep again. Sheila moves from a displacement of 0 metres to plus 4 metres in 2 seconds. What's her velocity? Okay, well, super. The velocity is just defined as the change in displacement, and displacement is usually given the symbol x. So distance is usually given a symbol d, displacement is usually given a symbol x. So change in displacement divided by the time taken for that change. So she started off here and she went to here. So her change in displacement is 4 metres, and the time it took her to do that is 2 seconds. So now I know her velocity is 2 metres per second, but because I'm talking about a velocity and 2 is a positive number, I know that she must be going in this direction, in the same direction as the positive numbers are increasing in. Okay, so hopefully you should be able to do this if you understood the video. Person A has got a displacement of 0 metres and a velocity of 1 metre a second, so that would mean A is here and going that way. Person B has got a displacement of plus 3 metres and a velocity of plus 2 metres a second, so that means person B is here and going that way with twice the speed, so I've given it a bigger arrow. Person C is at minus 2 metres and a velocity of minus 1 metre per second, so person C is going to be here and going that way with the same speed as person A but in the opposite direction. And person D is at minus 4 but a velocity of plus 1, so D is down here, but D is actually going in the direction of positive velocity, which is positive velocity is here. Sorry, my iPad's the wrong way around if any of the gestures were unusual there. Okay, and that's the end of the video. Thank you very much.